Alrighty. Hi, welcome everyone. So we are back with another stream today, and today we will be working on something new again, as it could be expected. So today I was thinking because I was working on Glasgow, this board. This is the project that we are working on to put on crowd supply. From the previous manufacturing run, as you might remember from a previous stream, I ran into a few manufacturing issues which I wanted to address. And while I was addressing those, I also wanted to fix the things a little bit more permanently. So for the previous manufacturing run, I did make some small changes, like make the pads rounded rectangles and stuff like that. But this was just for my manufacturing run. And I wanted to make that a more permanent change. So I talked to White Quark, and she encouraged me, as you can imagine, to upstream my changes to the footprints. Welcome to the stream. Thank you for subscribing. I will show you what the changes are that I was making on the next revision of the Glasgow, or I wanted to then contribute upstream to the Glasgow design, as well as trying to do this in a more sustainable way by creating the footprints in a way that we can upstream them back to KiCad into the libraries that KiCad provides. So yeah, let me just adjust the camera a tiny bit here. There we go. All right. So welcome everyone. We have a few people here, and this is our Sunday stream. And it turns out, I think, that we are having developing slowly a schedule. As I said last stream, that we have one stream during the week, one stream during the weekend. I'm still fluctuating depending on the workload and what other things and responsibilities I have, which day I am able to do the streaming. So I'm sorry that it is still not a fixed schedule, but rather announced fairly shortly before the stream starts. But yeah, welcome everyone, and thank you for being here. Let us look at what the status of Glasgow is, and what the changes are, and try to dive into the pretty deep rabbit hole that I ended up in yesterday. So this is the footprint, but let's look just at the PCB. So the two major changes that I did since the previous revision of Glasgow, which is the revision C1. So revision C1 is here. You can see it here. This is now C2. So I bumped the revision. And the two major things that were failing on the board were the level shifter footprints, as well as the ESD diode protectors. So if we look at these in the schematic, these guys are, I think, in here. Yes. So this is what is inside each one of this package. So it is a set of Zener diodes, right? Because of the reverse voltage, and they essentially protect over from surges, and they are connected to ground. So they reference the inputs to ground, and these parts, I think, are originally made for HDMI protection, but we can reuse them as single channel protectors for this project too, because it has enough diodes. We are not even using all of them. There are still 3 pins available on each package, and they are connected to a bunch of the I/O here. The problem I was having is that you might remember from the previous stream, there were ground pads in the center of the package. So these pads, we were not really using them because we are connecting ground directly on the pads here. So we have ground here and we have ground here. There is a ground, I think, even on this like center pad or something, but we are not even connecting to there. And because we don't have micro vias or a VIM pad at the moment, we didn't connect the center pad. So Markan decided to not connect those, and these were causing shorts to the outer pad. So as you remember in the repair video, we were had to rework these parts and basically squish them down to squeeze in the excess of the solder that was creating bridges. This will make it easier if we just don't have those pads because we are not using them anyways. So I removed them. There was already a footprint in the Glasgow local library. So how these things are organized, so we can look at that. If we go on change footprint, and then if we want to replace the footprint, we can go on the library. And then what we see is this is the Glasgow library here on the left, and then the footprints are on the right. And this is what we had before. This is the footprint we had before. And there is also a footprint that doesn't have the ground pads. And just from the nomenclature standpoint, this is a UDFN package, 18 pins, and it had 3 EPs, so ground pads, or I think, I'm not sure what the E stands for, but this is the notation how the KiCad footprints describe that they have these center pads on different packages. Usually there is 1 EP here. Welcome to the stream, PNR. Thank you for subscribing. Yeah, so that now that I replaced this, I also wanted to replace another part that that had issues. We had a lot of shorts between the pads on the level shifter. So these are the level shifters. So if we go on edit, this is the 74 LVC 1T45 DRL. I wanted to do, let's do this a little bit something a little bit more mellow. All right. So this part is essentially a bidirectional level shifter that can be switched. This is how all the I/O have the ability to be controlled in direction as well as be level shifted. We don't use the magical bidirectional level shifters. Oh, exposed pads. Thank you, Sylvain. Yes, that's our EPs. So exposed pads. That's what the EP stands for. So we are not using the bidirectional ones, the magical ones, because they never work well unless you control both sides of the equation. So if you really know what is connected on both sides of the level shifter, and you use those bidirectional ones, and you test it thoroughly that it always works right, don't use them. It's a bad idea. Everyone I know ran into issues with them. I definitely ran into issues with them. So this is why in here, instead of using the automatic switching ones, we are using ones that are controlled. So each of these parts has essentially 3 connections: an input, an output, and a direction select, as well as the power supplies, the input voltage and output voltage, so the reference voltage, as well as a ground. So the reference voltage is coming from all over here, where we have a DAC, so digital to analog converter, that is then connected to a settable voltage regulator. I think this is this guy here, if I remember correctly. And then this is essentially setting, I think this is this way. So this is the voltage regulator, this is the DAC, and the DAC is setting the voltage, and we can set what the output voltage should be. We have two sets of those on both sides of the Glasgow. So my problem was that because we were using this standard footprint, and welcome to the stream, thank you for subscribing. So because this was set to the default ones from KiCad, the distance between these pads was quite small. At the moment, now that I changed this, let me see, I think it is 0.2 millimeter distance. If you consider that there is 0.2 is now. I'm pretty sure this was less than that before. Also, when you generate the Gerbers, you usually create an additional opening from the pad to the solder stop of 0.05 millimeters. So that also subtracts essentially 0.1 millimeter from it. So you only end up with 0.1 millimeter thickness in here. So it is already very tight. No, I think it had to be less than that. I'm pretty sure I'm wrong with the number because I don't remember it by heart. Let's do, is that in mask? Nope. Preferences. It's in here, I think. In mask and paste, there we go. So currently minimum mask width is 0.09, but the clearance is set to 0. I think it should be set to 0.005 or something. But so if I don't set it, then the manufacturer of the PCB will increase the openings for themselves because they need the tolerance for the registration of the solder stop to the pad. So what ended up happening is, if we look at, do I have a PCB? Let me show you on a PCB what happened here, what was causing issues. Let's see. There we go. There's some Glasgows in here. Let's get a PCB. This is only one side populated on these. Let's look under the microscope. There we go. So if you look here, these were not that bad. So these were not that bad. I'm pretty sure the blue ones had more of an issue. So as you see here, there is a little bit of a distance, but the distance is not very big. And I was getting shorts on these, so this was not great. This other footprint that you see here, this is something I'm using on the Blackmagic probe, which has this longer center pad and wider and shorter ones on the outside, and it essentially helps pull the solder away from the gaps. I might still do some massaging on this and to improve yield. But we will have to see. Definitely, this is a recommended footprint from certain manufacturers, so I made that change. This footprint also ended up in the Glasgow standard library, so in the Glasgow specific project library. We also get the round rec pads while we were working on this, and this should be an improvement. What I also wanted to do is update the footprints to Upstream from KiCad, from the general libraries, because the librarians make improvements all the time. So the footprint of the voltage regulator got updated because this also had square pads, and then the SO8 packages also got an update. But if you look around, there's a bunch of footprints that still have square pads. So what is that about? There is a standard consortium. This is not JDEC because that's wrong. What was it? IPC, right? So IPC is a standardization body for PCB manufacturing. I didn't download it. I should have done that. So IPC, there's an IPC standard, and I forgot the name. Yeah, IPC PCB standards. I just had it out the other day. 60, no, 70. I'm pretty sure Sylvain just will pop out with, with the correct number for me. But anyways, so there's an IPC standard for PCB assembly. And there is a newer version of it, the revision C. And the changes in revision C, oh, I'm pretty sure I have it in here as a file in my downloads. Or no, I downloaded it on my different laptop. Sorry about that. So I downloaded it on my other laptop, so I don't have it. But the IPC 7351, there we go. Thank you, Sylvain. I think that's correct. That sounds about right. Let's try to get that. There's a table of contents. Someone also uploaded this, at least an older version of it. Yeah, generic requirements for surface mount design and land pattern standards. So this contains things like how you should design pads. There's also equations, how the pad sizes should be versus the legs of chips and whatnot. So it is a very good resource. Unfortunately, it costs money to get access to it, which is quite a bummer. So it is not really accessible to the average hobbyist, but I'm pretty sure if you Google a little bit about this, then you will get it. I could not find the newer version. I definitely found an older revision A. And here, this is the interesting part. If we look in this presentation, what is new in IPC 7351C, there are several cool things that they are improving. There's pad stacks, there we go. Like they changed from rectangular recommendation of courtyards, for example, to they added the body hugging one, so you can make denser designs. Then, so courtyard means do not put any other parts in this area around the pink stuff, just to clarify. So they added that. And also rounded rectangle pad shape is a new thing. And this is the new recommended pad shape. So all pads that are smaller than a certain size will get rounded rectangle corners, so corners that are around it. And it has a maximum radius of 0.25 millimeters and minimum radius of 0.01 millimeters. And everything in between should be 25% up and down. Oh, hello, Kriva. Thank you very much for joining the stream. So yeah, I need to do one more thing because I just remembered. Okay, there we go. So, so that said, this is essentially where all the pad designs of the footprints will be going. And now we can start looking into what KiCad does. And in KiCad, these are still the standard footprints in the library. They still have rectangular pads, and not all of them got updated into round rects. So what definitely got changed are all the capacitors, all the resistor footprints already got the rounded rectangles, and a bunch of the standard footprints already got it. But not everything, and I started looking into submitting upstream changes. So Bob is asking if there's a technical reason to make the rounded rectangle corners, or is this just a standard? First of all, it's a standard. Second of all, it is also a technical, so the fillets can be better. Also, makes it easier for really tight designs to etch those. So I am pretty sure, so I know that IPC does a lot of testing. So they create PCBs with all the different designs and all the variations, and then test reliability, how easy it is to etch, what is the machine requirement. And they have a lot of people from the industry contributing their thoughts and requirements and what they would prefer to happen in future design. So this is, I doubt this decision is just an aesthetic one. I'm pretty sure this has a lot of technical reasons. Yeah, so what you get definitely with the rounded corners is you can route wires much closer around the edge. So the rounded corner allows you to go around them easier. So I already saw that and used that a few times. Having the rounded pads actually allows you to tighten up your design just slightly more. And considering how dense today's designs are, I'm sure this is useful. I have seen people that are actually cutting off edges of pads to make routing work in certain situations. So there is definitely good reasons to do that. All right, so considering that, so I was looking into that and looking into the KiCad library and what the requirements are to contribute new footprints to KiCad. I could theoretically just change these in the footprint editor. So either I go just in here into the libraries and go on and change the footprint. So the easiest thing would be to take a footprint like this. All you need is to select rounded rectangle. It automatically chooses, this is KiCad's default, is the 25% thing. It will add that, then you save it. And all you need to do is go in pads, copy pad properties, and then you can select these pads and then shift the rest. Come on. 1 and 2, and then right click and pads, paste pad properties, and then they are all changed. So I could go through the designs and one by one just change them, or write a script that will change all the rounded rects in the library. So that would be one option. And I could essentially create a pull request and just send it in. Probably before doing such a dramatic change, I would send a message to the librarians and ask, it's like, do you guys want me to do this? I am pretty sure that they will say no, and they have a reason why they didn't just do that on the whole library. I think the main reason is that they are starting to use generators for a lot of the footprints in the library. And what the correlation I found is, if you look at the footprints that are generated by the generators, so some of these are, if we find one that is rounded rectangle, discard changes. Let's see, maybe SOP, nope. Yeah, there we go. There is one that has rounded rectangles here. And if we go onto the properties, we will probably find, no, this one actually not. This one is manually changed. But I did see that the ones that were auto-generated very often also said that they are auto-generated. Let me see if I can find something. SO4 maybe? No. TSUP, TSUP. These were auto-generating. They still have the square paths for some reason, but I'm pretty sure they auto-generated. Some of them do say here in the description that they are from the generator, maybe in a different library. So they are not fully consistent yet. I'm pretty sure they will be creating more consistent standards for this. So there's the KiCad KiCad standard. If we look here, KiCad library convention. So they do have some requirements, and they did not put in the rounded rectangle paths as into the standard yet. Maybe they will. They have automated tests to actually check the designs against the footprints against the standard. So I would assume that sooner or later they will add it. I have the feeling there is like that because the standard, the revision C is not officially released yet, they did not pull the trigger to change everything yet. Also, they just changed it as they touch things and as they update it. So thank you very much. Thank you for joining. Welcome. Oh, thank you, Vigorous Bog. Vigorous? Yeah, that's the name. Welcome to the stream. Thank you for subscribing. So essentially, I'm pretty sure there's a good reason why they didn't pull the trigger on it. Some of the footprints that were from the generators, and I'm very surprised that I don't see that on the first glance here. But if we look into the scripts themselves that generate footprints, so let's look in here. There's the IPC Gowling generator. This is what we will be looking at today. There in the description field, let's see if we can find that. Set description, generated with KiCad footprint generator. So yeah, so this is, and which script name. This is the convention they started using in different footprints. So most of them are using rounded rectangles. They might not have regenerated everything. And because KiCad as a project is moving now from being hosted on what was it, on Launchpad, that was previously for the KiCad source code, and GitHub for the libraries. Everything moved to GitLab, and the libraries are not moved from GitHub to GitLab yet, but as part of that transition, the scripts will become more of a prominent position in all this. They will be the default. I'm pretty sure they will get more cleaned up, and there will be automation for more of the generation of the footprint. So there is a very slow, considerate effort that they are moving towards automated generation of the footprint so that things become more and more consistent between each other. But that said, if I want to fix things for Glasgow and I want them to go upstream, I started looking into the scripts, because if I'm touching those footprints, just fixing them temporarily and not doing it in the script seems like wasted effort in some way. So I thought it would be better to look into those and create one of those dimension setup files and then run the script on it. Okay, so after doing this, I also started thinking, well, if I'm doing this, then I should get the most accurate information about the data I'm building those data files with. So I started looking into JDEC. So JDEC is this website here, or JDEC, I don't know what the pronunciation should be. And this is another standardization body that registers different package types. So Ed is mentioning if I need to rebuild KiCad to have scripting enabled and then generate the footprint. So I did not have to rebuild KiCad because it's possible that it is because I'm using Linux, so I don't need that. The scripting is in KiCad is a complicated topic on its own. So in some cases, parts of the scripting work and other parts don't. If this part that you are trying to use uses the UI, so WX widgets, to generate dialogues, this is less likely to be included because WX widgets does not work right and has Python versioning issues between different platforms. So you might need to do that. I did not need to do that because I'm using Linux, so it usually works without problems. I always can access the nightly build that has this stuff always built in. And third, I think these scripts are standalone. I don't think they actually use the Python scripting of KiCad itself. If then they use the Python library for symbol management that is part of KiCad no matter what, and does not require the scripting support to be built in because it doesn't use internal functions of KiCad. So anyways, it's complicated. It's not that simple. KiCad is quite a big, complicated project. But yeah, I definitely didn't. So let's run this script because I really quickly, because I was moving from my work laptop to this laptop. Let's see. Let's see if I can run this. So if I have packages going qfp soik, then if we look in the README, it says what to do. All I had to do here for installation is run the management script. Manage, I think. It was somewhere in here. Thermal bias, this is the standard itself. Oh, it is in the top level README. Anyways, so if I go in the, so generators, okay, I should also talk about this. So the generators themselves are a separate repository. So footprint libraries, this is still on GitHub if you look here. So it is GitHub, KiCad, KiCad footprints. This will move from here to GitLab KiCad, which is here, gitlab.com KiCad. All of this stuff is eventually moving over here. So that is the organization that you should refer to in the near future. So there's already KiCad libraries as a section, but this is so far empty. So there's nothing in here yet. But they are moving over there. And then GitLab, so on the KiCad, we have the KiCad footprints. So this library, this contains all the libraries and they are just static generated files. So you can either manually add files and there are pull requests. People are contributing a lot of footprints in here. There is a process for that if you have manual footprints. If you want to use the generated footprints, which is the recommended way of doing things, it is still not part of KiCad. This is still a personal repository of one of the librarians. So Thomas Pointhuber is the one that is maintaining that. But when they move to GitLab, they will be moving this repository or parts of the scripts over there and maybe even make a Python egg or whatever that you can install with pip that to get the library. So this thing also contains this special library that is more similar to OpenSCAD design of footprints. So that's another completely separate topic. But I don't think we will be getting that deep today into it. Still, the installation of this is fairly simple. I created a virtual environment And then all I had to do, let's see if this is in here. Running the script, and all you needed to do is, and I'm blind already. Yeah, this is doing it on stream and then already blind. Anyways, there is this guy, manage sh, and then all I had to do is run manage sh and then update dev packages. So that's one. Then I went into scripts and I wanted packages, and then the package going. This is something you find in the JDEC specification. There are several leg types for parts that you can that you are referring to. So there is a lot of the language here used also in KiCad. This is standardized. These things mean something and they mean one specific thing. So going is a specific type of leg on a chip. Same thing with JLead or LLead, and what is it? There are also for BGAs you have balls, you have bumps, you have pillars, you have pillars and some else. Anyways, in that document that I showed you before, the presentation for revision C, they talk about this language stuff, which is pretty cool, because then you actually starting to understand there are rules to this madness. Because if you just look at vendor footprints and vendor recommended stuff, you start definitely with time realizing, oh my god, everyone does whatever, and there's no rhyme or reason for things. But there are standardization bodies that you can start referring to actually tighten down what is the more broadly recommended way of doing things. So that helps a lot. At least it helps me to understand. It's like, is the vendor just being stupid, or am I being stupid? So it's usually I'm being stupid, but sometimes it is them not following the standard that is being given and understood in the wider industry as the right solution. So there is some hope in this whole madness. Okay, so we are in here, and I have the IPC Gowing generator, and I can just run size definitions as a parameter, and let's just do the SO parts. And there we go. So this generated the footprints. So it should have created packages SO pretty. That's so for KiCad, how libraries work, and this is how also libraries will work for symbols for schematic use when the new version of the format comes out. They are actually stored as singular files inside a directory, and the directory has the structure .pretty, and inside you have those footprints, KiCad_mod. These are the footprints themselves. So you could edit them even as text files, because the cool thing is they are essentially just text files. And if we open this guy, you see this is just sexpiece. So this is an expression from Lisp. So the S expressions, and people like to abbreviate it as sexp. Or I do. Yeah, so in brackets you have essentially the format, and you have, for example, an FP line. So FP line, and it starts and ends, and it's on layer, and it has a width so and so. So this is how the structure of the files is. So it is a pretty simple format that one could actually I did previously actually load this in Common Lisp and edit it as data structures in Common Lisp. And the problem was back then, I'm not sure, I think it is being fixed in near future. Some of the text fields were not quoted inside those files yet. And so it still is not, because, for example, fsilk s is not really a symbol. But anyways, I'm becoming here like getting down the path of Lisp and what tokens should be and what should be actually strings and stuff like that. But let's not go there. Anyways, so we now can generate those files. It seems to be working. So either I have the Python scripting built in into KiCad or it's not using it. I didn't really look that deep into the libraries that I'm using here. And the main library that this thing is using is the KiCad mod tree, which is part of the generator repository. So this adds all the machinery in the back to create this modular footprints that can be edited. And so these scripts, as per their like definition, they use the IPC, which we talked about just before, specification, how to calculate based on the physical size of the part and how long the pads are, the legs are, how big the body is, calculate what the fillet size should be for the solder, and from that derive the size of the pads. So it is actually using the recommendations from IPC to generate the footprints, which is pretty nice. This is something you also have in packages like Altium. If you go in Altium and go into the package wizard, the package wizard will ask you, it's like, so what are the mechanical specifications of your package? And then say there are 3 levels in IPC. It's tight, medium, and large for how tight your design is. And then it will generate based on that the size of the footprint. So the footprint either will be as tight as possible, but might be a little bit less reliable, or it will make it as large as possible to make it as easy for hand soldering, for example. So this is using those calculations, and there is IPC generic rules. There is a file in this repository that it is pulling in, IPC definitions, and this has this data. So if you see minimum, least, then nominal, medium, and most, maximum density. So this is the densities, and then we have the data for toe, heel, side, and courtyard. So this is toe. Toe is at the, if you have a chip leg, so you have the body here, then the leg goes down here. The toe is the size here, how much space you should have at the toe of the leg. Then heel is the backside, how much space you should have here. And then side to side, how much space you should have here. And then courtyard is around the whole part, how much space, this is the pink thing I was showing you before, how much space you should have around there. So these specifications are here, and not only that, they also have, these specifications vary on the size of the part. So if the pitch between the legs is above a certain amount, the rules change a little bit, and under a certain amount, the rules change also accordingly. So this is very interesting. The standard takes into account a lot of parameters. And doing it by hand, every time I tried to, I could not find a footprint for a part, and had to create my own footprint and feel confident that this is not complete garbage what I'm creating, and then doing all the calculations and finding the right parameters, it becomes very tedious. So this is very nice that KiCad essentially pulls in this data. You can tweak them. So for example, you can tweak inside the scripts if you want to extend the path. So for hand soldering here, for example, you don't use the IPC definitions. You basically say, please extend it beyond what IPC would recommend so that I can get with the soldering iron easier here. I personally don't use the hand soldering footprints because I usually target, it will only be soldered by hand for prototyping purposes. And then we will go with actual reflow manufacturing, so it won't be a problem. So I usually use the standard ones. But inside here, if you look in the library of KiCad and you find a footprint that says for hand soldering, or hand soldering as a suffix, this is what they are using. They're just extending the pad above the IPC size. Okay, so now that we, I hope I'm not boring you guys to death, but I find this all very fascinating and interesting, how footprints are being generated and where the standards are and what specifications we are using to create them. And at the end, it is just running the script and generating them. What I find interesting is the size definitions. So far, I could not find a way where I can say, this is this specification and create footprints with the pin count from A to Z, at least not in Galwing. I know this is a part of the connector script generators. They generate footprints for connectors using those scripts. And they basically say, it's like, yes, start from 2 and then up to 20 and generate all those footprints. Here in Galwing, I don't see that. I have the feeling that might be just work in progress, because I see these scripts, if we do on git log, the Galwing generator. So René Puche, he is the amazing guy who does a lot of the librarian stuff. It was, yeah, the last update was on January 27th this year. So there is very active development happening here. Yes, September last year were some improvements per comments and improved documentation. So there's very active development happening on the scripts end of things. I have to look inside and see if we can generate, for example, TS-SOP footprints for all the JDEC sizes. And now we can actually look at what JDEC says about a footprint. So the standard for footprints is registered through JDEC. Again, at least you don't have to pay to access those in this case, which is the case with IPC. But you need to create an account here, and all the documents will be watermarked with your company name and stuff. So I didn't make an account. I hope that when I show these PDFs on here, I will not get in any trouble. But I think the main reason for this is that they don't want just copies of those files that might be outdated to float around all over the internet and then basically confuse people. They want to keep it in one spot and make sure that people don't distribute and leave outdated documents all around the place. So that's the main technical reason I can imagine of them doing such a thing. But I'm sure it is also related to older rules, because you can buy hard copies of all this, which is a legacy thing these days. I guess you could get a hard copy for it, but these are like full cabinets. I've seen those JDEC documents at one of the contract manufacturers I visited. They had full like metal racks full of documentation for footprints, which is, yeah, that is not what. I think it dates you when you have those. All right. So if we look through here, there's this document, which is the JEP. So this is the JDEC publication 95. And this is an overarching document that contains all footprint registrations. And this is how they call the standards for different footprints. So for JDEC, it is a free registration. You don't have to pay for it unless you want a hard copy. I didn't even look how much the hard copy costs. If you buy a hard copy, it's $1,500. Yeah, including shipping, and then annual updating service is $135 per calendar year. Yeah, and there's like I'm not exactly sure what 21D was, But yeah, the 95 is the standard that interests us most here for PCB layout. But yeah, you can download the PDFs for free. So you can, but the problem is you cannot get them in one big chunk. You have to find every single one by one. So it is a little bit annoying. To a certain degree, I wish there was a scraper script that one could use for oneself. But I'm pretty sure they would ban me if I started like scraping the PDFs from the website to make the navigation easier. Anyways. I hope things will progress over there too, but it looks very outdated and quaint somehow. Okay, for the other standard for the, let's see, for the IPC standard, this is similar pricing. Yeah, IPC. Let's see what the IPC standard costs. This is just the table of contents of IPC. Yes, that would be good. Definitely let me know when you have it. Yeah, so this is IPC. They just had the expo, I think. Online store. There we go. It's also like $1,500 or something, somewhere in that realm. No, it's less. IPC. This is a different IPC. Let's look. We want the. What did we say? 7351, right? 7351. I looked at the standard itself. It's really so. It's very useful. There is some very interesting, useful information in there, but I find it fairly overpriced if I wanted to buy it. It's really expensive for what it is. Why is it not opening it? 75. No, 7351. 751. Still not here. Why is it not finding it? 7351. Yeah, there it is. The B is the current one. Oh, it's not that bad. It's $168. It's still a lot, I think. And if you are a member, so you pay dues, I think being part of IPC or being a member has the advantage that you can do some voting on certain changes. And I think the main thing, you might need to be a member if you want certification. I am not sure. I know that that the CM that I had contact with, they were members of IPC. They had the hard copies of the JDEC standard and stuff like that. So I'm sure there are some perks and reasons to be a member. And also getting those standards for cheaper, especially if you really want to make sure it's like, yeah, I have this standard, I can always refer to it, and I'm all legally 100% in the clear then doing this. And consider Is the audio back? Ah, there we go. Yeah, the battery ran out in the receiver for my lapel microphone. Sorry about that. All right, so where were we? Yeah, I should find a way of powering this thing from some power source instead of using batteries. I know I use the Sennheiser EW100 as a lapel microphone so that I can stay connected with the microphone while I'm scooting around in the room. I think it does have these connections for power, so yeah, this is really annoying. So yeah, I have to find some way of either connecting at least the receiver permanently to power, because that is not really moving around. And then I should start using rechargeable batteries, at least for the mobile one. Yeah, it is a bit annoying. It's like, just give me a damn 18650 huge battery in that thing, then it will last for several days of running, and then I can recharge it when I need to. So yeah, so I know that it's like I have a friend who is also an audio engineer, and yeah, they have a lot of half-used batteries, because these things don't even run very well on rechargeable batteries. They don't last as long, and they don't use them fully. It's really annoying. Yeah. Anyways, thank you, Ed. And so, where were we? We were at the JTAG standard, and we were trying to look how I found a specification for the footprints that I want to do. So first of all, let's see which footprints I was thinking of adding or fixing, updating. If we look in here, so these are the ones that I wanted to address. So if we go on Edit and then change footprint, we see these are TS sub 16 and 4.4 times 5, and then 0.65 millimeter pitch between the pins. This is the one I wanted to look into. So, but the main thing is we are looking for TS sub. TS sub is what we are looking for. So I went through here, and microelectronic outline. This is the category mainly of the footprint. So there are two main categories that are interesting when you are looking for. There are some diode outlines if you are looking for diodes. There are some transistor outlines, for example, SOT23. Track, yeah, there's an adapter to be built for 18650s. Yeah, I think that it's another yak to shave. It's another day. So, complete tangent. I have a DECT phone that I finally brought with me this time from Europe, because we use at CCC at the Congress, there's a huge DECT, so wireless telephone. This is a European wireless telephone standard. It's called DECT, and there is a huge DECT network at CCC at the Congress, at the camp, and other events that are CCC related. So people use them as basically as their phones. When you want to contact someone of the organizers, you just pick up one of the DECT phones and you can call them. There's a public list of phone numbers, and the problem with those is they also need recharging. And when I'm going to such an event, I don't want to think about charging my phone. I always fail at this. I then end up with having no phone. People cannot rely on me having a phone. So it's really annoying. So I saw someone at CCC, one of my friends was like, yeah, I just bolted onto the side of my DECT an 18650 battery, and it lasts a week.
and I'm done. I went to camp last year and I didn't have to charge it once. Perfect. This is the mod I really want to do before I go to the Congress in December again. So that will be very nice. Another side projects that on the to-do list. So yay. Okay. So this is the standard we are looking for. Then we have a device tab. This is a PDF that it opens. In that PDF, we have a list of different footprints. There is the footprint we are looking for is TS-SOP, and they have multiple widths of the body width pitch, and I don't see 0.65 in here. That's interesting. 4451. But anyways, this is the number we are looking for, so MO153. And then after having this number, let me go backwards a little bit. You just type it into the search field, you search for it, and then you can download the PDF for that footprint. So now we finally found the original source of the standard. So if you look even at how I read how weird the process is of them standardizing a footprint. There's a flowchart in one of the documents. It's hilarious. I have to show you still. It's just too good. Submission state product outline drawings. Yeah, I think that's what it is. Is that here? There was a flowchart somewhere. Oh, there it is. This flowchart. It's just perfect. It's really a standardization consortium typical thing. Somehow you register a ballot, then you bring your copies of the outline, so of the package you want to use. Then people vote on this. They have editorial review of the packaging. They prepare ballots. It's like a weird mix of technology, tech, and politics. It's so strange. And then you report it at the next meeting, and the results, and then you have to make 50 copies, I think, of the package to hand out to people. Then you get some results, and then you have to review it and go back make new versions of the packages. It's just hilarious somehow to me. But yeah, standardization consortiums. Yeah, so this is the document that you end up with at the end. And it essentially contains something you would find in a vendor document, but on the second page, there is common dimensions. So this is the dimensions we will be referring to. So yeah, this is what we are looking for. We are looking for the 0.65. It's all in metric, so by the way, as far as I know, all of this standard stuff, at least the newer designs, they were all metric. So that's nice. It's obviously the world is turning and moving forward. So 0.65 is what we want to change. So this is the specifications we need, and we will be using those. The question is, where do they say from what the pin count plus minus is? Because I think there should be a list. I think it said it here. Yeah. It said pin count is 8, 14, 16, 20, 24, 28, and then up to 68. So I think this is the specification how many pins this package can have. And from the package, then we use the IPC standard to actually calculate the footprint. So that's the plan here. So all we want to do today, after spending an hour just talking about the standards and whatnot, would be nice to at least add this one footprint that we started with. So the footprint that there is no TS sub. So this is thing. This is shrink. So thin shrink. What do they stand for? I don't remember. What was it? TS sub. Wikipedia. That usually says in the Wikipedia what the thin small outline package, that would be TSOP, and this is thin shrink small outline package. So yeah, that would be TS-SOP. And I only see thin small outline package, and I found that also in the IPC standard. There are two types of TSOPs, the type 1 and type 2. If you look in KiCad and you see those footprints, you're like, what is this 1 and 2? It is actually IPC standard. So I think 1 is the wide one and 2 is the narrow one. So if we look in here, yeah, see the, if we go TSOP, so TSOP 1 is the pins are on the side of the shorter side, and type 2 is on the longer side. So that's how you know which TSOP you need. HTS SOP, high temperature shrink something. Oh, is that HTS SOP? Is that the same thing? You might be right that this is the same thing. I think this is the high temperature ones. So the one with the EPs, with the electrical pads. Yeah, I think HTS sub stands for high temp. Yeah. No, good point. Good point. Thank you for asking. Yeah, it's HTS sub. Let's see. Yeah, they have all exposed pads. See? So this is for basically for heat sinking. So that's my assumption. Let's see. Yeah, let's find this footprint in the IPC JDEC standard. Let me close this. I don't care anymore. Oh, I don't have it here. Interesting. It might be in a different section. TI. HSSOP. Storm Corp. Welcome to the stream. Thank you for joining. Thank you for subscribing. Yeah, so what is a PowerPad? Yeah, PowerPad SSOP. Yeah, I have the feeling this is what it stands for. I think, yeah, the interesting thing now would be if why are they still not round rect? I don't understand that. I thought I changed preferences. No, not preferences. That I'm using the newest library. Yeah, KiCad footprints. This should be the newest. Packaging terminology. Oh, your lurking has been exposed. I'm sorry, but thank you for watching. Lurking is very much welcome. Yeah, so terminology, let's open that. Thank you. Copy link location, there we go. Yeah, we are learning together. I find these things super fascinating. I spent whole yesterday just doing this kind of stuff, just digging through documentation and trying to figure out how this world works. BGA. yeah, thermally enhanced thin shrink small outline package. So yes, TS sub would be the ones without the electrical pads. All right, so that's confirmed. Thank you very much. So yeah, we will be creating a new file just for TS sub. Again, as I said before, what I find weird is that this script doesn't generate multiple sizes. So I can't, as far as I have seen, I cannot just create a footprint and say it's like, this is the pattern of like in general, these are the common parameters, and please create all these sizes with this pin counts for me. This is something we might need to dig into sooner or later, but I definitely am not doing it today. So yeah, but still interesting. Okay, so we can take a look at least how they're defining a footprint in here. So what it does, so the standard of the naming, I'm pretty sure this is manual written. So we have type of package, pin count, one exposed pad, then we have 4.4 millimeters by 5 millimeter body size, 0.65 millimeter pitch between pins, and then it has a second. Oh, and this is the size of the exposed pad, because the interesting thing is too, between different footprints or different packages, you can have Gonzo. Thank you very much for subscribing. Welcome. They can have different exposed pad sizes, so you might need to adjust it. So you can have essentially the same footprint or the same package otherwise, but the pad is different size. I did see that already, so this is why we need to pay attention to this. Then what the source is, where we got the specification, I have not seen any of them refer to the JDEC standard so far. So that's interesting. Maybe this is a rule that the size reference quoted in here should not be behind any registration wall or paywall, which makes sense. Like paywall, I 100% understand. The registration wall, yeah, I could probably be okay with that, but this is their decision from the KiCad developer, so I'm not really questioning it. It's fine. Then we specify body size, and we specify as a minimum and maximum. It takes the average and uses that in the calculation with the IPC, and we put those in, then the pitch of the pins and number of pins in x-axis and in y-axis, and that's pretty much it. The rest is the exposed pad, which is the nominal size, x, y. Yeah, you can put in either min-max or what the nominal size is, and then you can also add a tolerance. So depending on how it is written, this is the nice thing about the script actually. It takes, if you have a drawing from the manufacturer, they sometimes go with min-max, sometimes with nominal size plus an error, and sometimes just with the nominal size. So you can type it in as it is in the datasheet, which is very nice. Yeah, and then the pattern for the thermal vias, which are the holes in the electrical pad, and we specify them here. I would love to see a more graphical editor eventually for this kind of stuff. That would be so cool. I'm sure sooner or later someone will build that. Yeah, for now we have to just do it in text, which is fine too. Okay, so let's create a new file, save it as YAML, and let's look at the top. The file header is what library and what device type it is. And then we should start with TS. Let's just copy this over and just edit this. That should be easier. Yeah, let's copy the whole thing and just adjust it. That's the easiest way. There we go. Then we do TS sub, and we want, was this also S16? TS sub 16, these are the sizes. We can just copy it over. Yeah, actually we copy it over from here. All right, so now we can actually copy this over. Let's see, was it also with an underscore? No, with a dash. What is the current standard? This is something I'm confused about, because they changed if this is a dash or an underscore between the 16 and the... Oh, no, there is an underscore. It's just the exposed pad thing. Okay. Let me just do this again. There we go. This standard should be, yeah, we should write here. I probably will have to Hi Dick Shadows, thank you for subscribing. Thank you for joining the stream. So we need, so the IPC standard we are using, this is the MO153G. Yes, so this is the definition we are using. Let's just do this, because we cannot really link to it. We could link to the MO site. I'm pretty sure you can just open those, and then it will ask you to subscribe, I think. I should copy this. Search API, no. Can I have a, yeah, let's just do this and then create a private, nope. Will that, yeah, private, where I'm not logged in. Let's go in here and see how that looks. Yeah, so free download, registration, or login. Okay, so we could link to the page where the standard is. I'm pretty sure the KiCad devs will, the librarians will say it's like, no. But let's do it for now. Okay, so let's just put it in here. And now let's go into the file and look at the spec. Where is it? Oh, I think I closed it, right? Yep. Okay, so what do we need? We need, this is something also described here. This is why you need more monitors. I need more monitors. There we go. So overall size is with the pins. This is the interesting thing. So overall size, body size, exposed pad size, lead width, and pitch. That is pretty clear. Lead length and overall height. Right. So overall size is with the legs, and body size is just the plastic. Okay. What do we need? We need body size X first. Oh, and in I have 2 monitors, yes, but 3 monitors would be ideal. I need to expand my monitor count, my main working machine. To be fair, I actually have 3 monitors because I have my main working computer has 2 monitors. And then I have a laptop always on the desk too, so I have it as a 3rd monitor. Does that count? Yeah, I don't know. Yeah, at least I have two monitors, three times 4K. Oh wow, yes, that would be wonderful. Or even have like two of this like really wide curved ones. That would be pretty sweet. Oh, with tiling? Yeah. Yeah, that's quite a battle station, right? Alrighty. So, body size X and body size Y, then body height and overall size. So it doesn't have, interesting. So we don't have the overall size for Y because there are no pins there. That's very cool. And then lead length. Minimum, nominal, maximum. Okay, so we need E is the overall length, so body size X. Oh, what I was trying to say. The IPC standard also defines what the rotation should be of parts in the libraries, how you use them. So the libraries that you use for PCB design, they do specify what the orientation, the standard orientation of the part should be. And in the IPC revision A and B, it said the pin 1 should be in the left, like for you, in the left upper corner here. No. Do I say like, yeah, left upper corner on your end? Man, I have to rethink. And now it is actually in the left lower corner where the pin 1 should be. So that's the C revision. They are planning to change that. So there is already confusion happening in the libraries of KiCad because some parts are already rotated for the upcoming standard and some are not. So yeah, I think we will stay with the left upper corner for now because I think this is what it is. Oh no, it is left lower corner. Wow, it is left lower. Okay, because it was left upper so far. Okay, well, so this will be in, we will have pins in the x-axis. Is that right? Yeah, so it will be 8 pins in the x-axis. The pitch is the same. Then body size X. Overall size. Is this a reverse thing? I have the feeling somehow that numpins X is actually... Let's just leave this because this is weird. Huh. Oh, right. The overall size, yes. It will be reversed. That makes sense. You're not having it visually in front of me is what confused me. So you have pins in x-axis, but the width will be increased in the y-axis because that's where the pins poke out into. Okay, fine. So body size X is this one, so it's big D. Let's go to big D. If I can find it. So issues. .65 pitch. D basic, E1. Oh my goodness, there's a lot of variations. D basic. Body width. Oh, good. Nominal. TS sub variations. Should rotate this. Oh, this is where it begins to become interesting. So this is 0.04 pitch. We don't care about that. 0.65 pitch and body width 6.1 nominal. 8 nominal. Ah, so wider bodies. That is very interesting. That's why we have this here. So 4.4 is, that would be x. X is body size. So this is basically how wide area you have between the pins. This is not related to the pitch of pins. So this would be 4.4 and we have to rotate that. So we have to swap these because we have to rotate this. Right? Yes, because the fixed one is the 5 because it is 0.65. Well, there we go. I wanted to actually open this. There we go. I want GNOME calculator. So 0.65 times 8. So this is 8 gaps. Yes, because it also. Yes. It's 5.2. It probably means. Oh, it is minus probably. It's the nominal width. So it is probably less beyond the last pin. So it is probably 0.1 millimeter less. That would make sense. 0.1 millimeter is not that. It's. So basically the plastic body width beyond the pins is just is 0.1 millimeter less than usual. Oh yeah, you are right. I should just reference how they did it on the other pins. So this is this old standard where the pin 1 is here. Is there any? Yeah, I have to find one that is already rotated. I'm not sure it is even in this library. Might be in a different library. Maybe they didn't rotate them, any of them yet. Then I should stick to the old standard then. Yeah, it's not promising. It might. What? That is weird. Why is it on the right side? Yeah, I think this is still. Yeah, I think you are right. They didn't change this yet. I had the feeling they changed it in a few footprints, but I don't see it. I wish I could just scroll through these and see what they are. BGA. What does BGA do? Yeah, they're all in the left upper. Well, I guess we're sticking to the old standard for now then. That's probably the safer solution. Yep, okay, let's stick to the old one. Thank you for reminding me to test it. Okay, so this goes on here, this goes on here, and then we do X, and then we say nominal X. Yeah. E1, that's the body width. E is the overall size. And this is D. 2, 3, 4, 5 notes. Where are the notes? All dimensions are in millimeters. 2, 3. Dimension D does not include mold flash, protrusions, or gate bars. Mold flash, protrusions, or gate bars shall not exceed 0.15 millimeter per and. Dimension E1 does not include internal flash or protrusion. Interterminal. So basically, if you have pins between the legs, there's sometimes a little bit plastic also squeezed out. That's flash. Tie bars, burrs, gate burrs, and yeah, this is basically covering your bases for manufacturing quality. 4 and 5. Datums A and B and dimensions D and E1 to be determined at datum plane EH. Oh, so they say at what height we. This is very interesting actually, because I run into this issue a lot when I'm setting up the pick and place machine. My positioning system looks at the plane inside the part to determine the rotation or the offset of rotation and position offset, as well as the dimension of the part to make sure that it shouldn't be rejected because it has a weird size, because it flipped or something, or it's the wrong part. So I have to tell it at which height from the nozzle to measure the size. So this is reminding me of something that I have to deal with on a regular basis. So H, at the plane H. Where's the plane H here? Max D. Do they define it somewhere? B, detail C. Yeah, there you go. Here, that's plane H. That's very cool. So it is right below the pin. So essentially, you measure it just after the bend, more or less, of the part, if you measure the size here. Huh. And it's only for certain dimensions, right? Huh. That is so cool. I learned something. If I measure parts, I should be measuring them in that spot also, especially when I use this as a reference for sizes. 0.5, it's not what I want. I want the 0.65, 4.4 millimeter nominal. Yeah, this is 6.1, so this is the 4.4 millimeter nominal. Body width, and the tolerance is 0.1 millimeter. I think that's correct. 4.4, 4.3, and 4.5. Yes, that's the same. Body size Y should be. That's the interesting part. AB1. What does that mean? Variation. AA, AB, AB1. Huh. So they have 3 millimeter. Yeah, that's the. So one is this variation in the different distance between. So they can have them wider than the legs. Is that what it is? There can be additional plastic beyond, or less plastic than, because this can go 3 millimeters, 5, 5, 5.6.5, 7.8, and 9.7. So if we punched in all those variants into KiCad generator and just generate the complete library of it, that would be pretty cool actually, to have all the different variations, just dump them in there. Yes, thank you. I can rotate the page. I think it is also here. Rotate clockwise. Thank you. Yes, I appreciate it. Yeah. Otherwise, I get a cramp in my head or something. Okay. Oh, this is the number of pins, isn't it? But it's 14. N 14? Did it rotate all the pages? I think it did, yeah. N is 14, not 16. Is there no 16 version in here? Pins 8. Pins 8. 8, 14, 16. Yeah. Yeah, this is B. E is the gap. Then the size. Let's look at the size of the legs, because I think this should be not variant dependent. Now I'm rotating my head the other way. Well, to balance it out, I guess. This is the cross section of the pin. That's also cool. It's like you have base metal and what the plating is on it. It's going into a lot of detail. Also, what is the radius of the bends? Minimum. Huh. So cool. Okay, so 1 millimeter is the length here. Then the foot length is 0.6 millimeter. The title of the page had the reference of the body width. Yes, I saw that part. So we have, what we are looking for is the not 0.5, but the 6.5 pitch, and then body width E1 of 4.4. That is clear. Then we want 5. See, there we go. Okay, so that makes sense. So the 16-pin version and the 14-pin version have the same width of the package. That's interesting. So the N number is the amount of pins. SD basic. What is SD? What is SD again? Let's check it. Yeah, this is why you want this thing also open in 3 places. SD is the, right, because one is even, one is not even, so the SD is the distance between the center of the package and the first pin. So it when you have the not even number of pins per side, then the SD will be 0, and if you have a even number of pins per side, then you will it will be half of 0.65, so 0.325. Let's confirm this. Scroll, 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 scroll. SD basic 0 and 0.325. Perfect. Okay, so I think we know all the IDs. The A1 is something I probably should check what A1 still is, but D is also 0.1 millimeter distance, so that's body size Y. Then body height, that's probably the A1, yeah? Minimum, maximum? No, that's something different. Body height, I think, is fixed. Overall size. Plus 2 millimeters, right? It's 5, 6. Shouldn't it be 7? Overall body size should be with the pins. Yeah, if this is 1 millimeter, then it should be 7 millimeters wide, including the leg. And then lead length 0.6 millimeters. This is correct. 0.6 and then plus minus 0.15. So 7.5. 7.5 and 4.5. That's correct. Lead length is correct. Lead width is just B. B, 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 B. This depends on the reference. Common dimensions. 0.2, 0.16. Yeah, 0.19, 0.3. 17. 2.3. In the first batch, 065 basic. Oh, 065 basic. Yeah, you're correct. Yeah. So B would be 17 to 30. 17 to 30. For B, for the overall width. Yep. Okay, thanks. Yeah. Yeah, 1730. This is the one we want. This is 065 basic. Yeah. Yeah. You are right. Thank you. And pitch, overall size. We still have to figure this one out. What is the A1 also? E1, big E, and then E1. Still the A1, what is it? A. That's the plane. Detail A. Where do they have A1? Should I rotate it back? Datum A. Let's go back to here. Yeah, A1, this is weird. The E, oh, 6.4. There we go, E basic. That's 6.4. And it's nominal 6.4. Okay, overall size. And then does it say what the error is here in the basic? Doesn't really. It's probably the same one as the body size, right? Oh, there's like a bend of the how long this is. Is there an error for the bend of the legs? It might be related to the mold release angle is 12 degrees. That's good to know. Man, the details that this drawing has, it's you don't get that in a data sheet of a part. This is pretty cool. I like that. Yeah, I think we are good. We are pretty much good. So yeah, I think this is correct. We could also go and create more of them, but let's just generate this guy and see how this looks. Oh, there's still HTS sub here. Should delete that. Let's do this. TS sub and part for parameters sec TS sub 16. Package SO, pretty. And then TS sub, perfect.
and we should what is it? Control A. There we go. And then copy this into. Come on. What happened there? Okay, I'm confused. KiCad footprints git, and then package so.pretty. Okay, so let's open the previous one just to make sure how it looked. TS sub 16 4x4. This is the one we had. Now let's copy it here and close and open. Ah, round rect pads. Very nice. I think it is slightly bigger. Yeah, let's see how, because these were the same, right? No, I think this is just the text length. It's changing the perspective. This is very cool. Now we have that footprint. That's nice. Yeah, I can now essentially... Yeah, Ed, that's a very good question, how often they actually comply. So far, I have seen they were so far essentially for, especially of the very standard packages, they were pretty close to the I'm not sure about JDAC yet. I would have to check that and like start using that standard more as a reference. But it's not as far, especially when I'm coming to this from the perspective of taking the design and then looking at different manufacturers' datasheets, because that happens quite a lot where you want to cross-check that you didn't make a mistake, or you cannot find a footprint specified for the part by the manufacturer. Now that I can start using the IPC calculator and more often, then I will probably start like converging on that more. What is also cool with this script, if more of the library can automatically be generated this way, you can tweak those parameters for the footprints and say, it's like, for my manufacturing, I need to have this or that adjusted a little bit versus what IPC recommends, and then regenerate all those footprints. I find that very exciting opportunity here to actually tweak the designs of the footprints for the whole library so that it is closer to what my requirements are for reliable assembly for the manufacturing process that I use. This is something I'm really looking forward to be able to use. Even if I don't use it, it's nice to have like a backup plan there. So yeah, we created the footprint. This is very nice. Now, what I can do is go in to here. So I can contribute this footprint now. I will create a pull request, and then I will create a pull for both repositories, one for the footprint for them to review it, and one for the script or the parameter script that I can contribute. And then from there, I can continue also changing the other footprints. So let's change this guy, and then change footprint, and then just change footprints with the identifier, and just apply. This will automatically replace it with the same name. Ba-bam! Wonderful! It looks great. I'm glad this seems to be doing... Let's see. If I go back, how does it differ? They are a little bit different, aren't they? Just definitely not as wide. Huh. So... that's interesting. Huh. And they are not as wide. They are a little bit denser based on the IPC.
versus what the vendor, probably this is copied from some vendor. That's so cool. Okay, that's really nice to see. Interesting. So generated based with from the JDEC or the IPC calculation. Sorry, I'm keeping mixing up consortiums. But yeah, this is nicer and denser. I had similar issues with resistors and capacitors in the past, where the vendor definitions were much more generous than the actual standard required. So I shrank it for my own libraries and I didn't have any issues. It was just I had more space on the board or could squeeze in more stuff onto the board, which was nice. Yeah, so that's that. One additional thing that I will have to work on, other parts besides this and the these guys here on the end, which are the ADCs, and they use MSOP as a package, which I can pretty easily add to the library or to the generator. There's also all those SOT parts. So not this. This is the SOT. So there's an SOT23, SOT23-5, which is the 5-pin one. There's SOT just 23, which is just the transistor footprint, which interestingly is, according to JDEC, the first SMD footprint for a chip. I had no idea that this is the first plastic case package that they ever made was the transistor one. I saw that somewhere reading yesterday. Before, I think not even diodes came in those small glass tubes back then yet. So this is very interesting. So yeah, the problem is there is no good script to generate those. These look simple, but the problem is the script assumes there is the same amount of legs on both sides, so it cannot. I cannot mark certain legs for not existing, which the script should support. So there are certain features in the script and the configuration that I think I should start adding. Is the ability to say these are the parameters for a footprint, and these are the different pin counts, and calculate the rest, generate those, as well as SOT23. You are missing leg number 2. You are missing leg number. Like if you have just a transistor, you're missing leg number 2, 4, and 6, and then renumber them correctly. Or you have 1, 3, 4, 5, 6. Right? What is this? No, 1, 2, 3, 4, 5 is missing, and 6 is here, as well as the full 6-pin one. There's also an 8-pin version of the SOT23, which has narrower legs, but I think that requires a separate specification because the legs are different and the size is different. This new footprint has a better clearance between legs. I like that. I did not have problems with shorts on this particular part doing Glasgow, but it could have happened. Another thing that needs also to be done are resistor arrays. They also don't have a generator for resistor arrays. This is a 8-gang 10K resistor array, and these, obviously because it's square, you can see this is not auto-generated. So I will need to fix that. So there's a lot to contribute to KiCad on that front. But I hope this will be not too painful. And if they reject my contributions, that's fine too. At least I will have them for my own local library. Okay, so I think that would be it for today. We are getting to a close. I hope you enjoyed this a little bit, maybe learned something from all that. I definitely had some fun sharing the process of creating footprints, what the standards are, where is using them, how to access them, how to maybe even add new footprints to the generators of KiCad. So we went through quite a process here, and I hope this will be useful to you and you will find some opportunity to contribute to KiCad so that everyone can use it. I find this kind of effort, it takes a lot of time, but at the end, you are saving not only yourself time later, where you don't have to hand massage the footprints on every board you make, or someone else sends to you, but also you save time for others. So I think this is a worthwhile endeavor to contribute to this. So that said, as always, thank you very much for the patrons that make these streams possible. This is really helpful. So the shout out goes to Ed Borden, who is here in the chat even, to Jerzy Hacker, Jordi Parker Rodriguez, and Sid Price. Thank you very much for your support and making this possible. Yeah, and that said, thank you very much. Thank you for watching. And if you have been, thank you for being here. Bye.